Well, come on, you math majors, if you want to be free. From corporate America, you listen to me. You got a sequence that you built from your approximating tweakins. You really need to find a convergent subsequence. So you ask my man Bolzano and his homie Weierstrass, and they show you a solution with a trick that's really boss. Well, are you down with that?
We're down with that.
Say, are you down with that?
Yes, we're down with that.
Well, you haven't got much hope unless your sequence is bounded. So let's say some interval has got your numbers surrounded. They're all greater than A, they're all less than some B, and it's right there with those points that your thoughts have to be. So to your right is B, and to your left is A, and in between the sequence tries to wind its way. An infinity of xn's this interval has in it. Still you don't know where to look to try to find the limit. So you stand in the middle, halfway in between A plus B over 2, if you know what I mean. To your left a line segment, half the big one size. To your right another one, in the same way lies. And every xn lies in the other or the one, but kid, you'll never believe what this division has done. You see, if every xn lies in one of these two, then in one or the other an infinitude. Well, are you down with that?
We're down with that.
Are you down with that?
We're down with that.
So you slide to the side, this infinity lies, to the middle of the interval of half the size. This new interval, I said it's half as long, contains an infinite subsequence if my logic ain't wrong. Now you do it again, divide the line in two, and if you paid attention you'll know just what to do. You count up all the xn's on the left and the right. There's infinity in one, though the space is getting tight. Now you do it k times, things are really getting small. 1/2 to the k is your interval, yet within this little space, within this little bound, a whole subsequence can still be found. Yo, are you down with that?
Yes,
we're down with that.
Well, are you down with that?
We're down with that.
You can do this forever until Tish above. 'Cause infinite recursion is a thing that we love. A chain of nested intervals, each inside the last, like little Russian dolls, and they're getting smaller fast. But what you have to believe, because then we're nearly done, is there's exactly one point that lies in every one. See all those left end points, they have to have a supremum, the same way that the right ones need to have an infimum. Well, this sup and this inf, they lie in each of these sets. Oh, the distance that's between them is as small as it gets. They are both the same point, so I say what the hell? I think that it's a limit, so let's call it L. Well, are you down with that?
Yeah,
We're down with that.
Say, are you down with that?
We're down with that.
Well, I promised a subsequence and I never tell a lie. To distinguish this from X, I call my sequence Y. Recall the kth interval and all the points that it spans. Well, I only need one, 'cause that's how bad I am. Why, K's my name for that point. It lies in interval K, which makes it quite close to L. You see, I planned it that way. Now you can pick epsilon as small as it wants to be, 'cause I got nested quantifiers and they're working for me. I will come back with an M so big I'm sure it will do, which of your epsilon is 1 minus the log base 2. You see, the thing about M is that I picked it so good that after it the YKs lie inside of L's hood. L's hood is epsilon size, so all the intervals lie in it. QED, you got a sequence that converges to a limit. Well, I am out of here now because my rap is at its end, but I'll leave you with this exercise to prove it in RN.